So for 36, they want us to use a graph to find where these curves intersect. So I've gone ahead and I've put these graphs into Desmos so that we can see these points, right? And that we can see these points go from 0.772 all the way out to 1.524. This ends up being quite a crazy graph. So we know that our integral is going to go from 0.772 all the way to 1.524. And so we're taking this area here that's between them, and then they want us to revolve it about the x-axis. So to revolve it about this line like so. Now, when we revolve it about this line, we're going to end up with a washer, where the lowest part of the washer is going to touch the blue curve. So this curve right here, it's going to go like this. And then the highest part of the washer is going to touch the red curve. So this one, and it's going to go like this. Yeah. So we're going to end up having this disc-looking thing, and then we're summing up these discs across the x-axis. Now I've drawn these quite badly because they appear. Let me try to maybe draw them to the side like this. So that's our first one, and then maybe I'm going to draw my other one a little bit smaller. Yeah, it's gonna go like this, I think. All right, so once we have this, all that's left for us is to see how we can calculate it, right? That is a bit higher than I was drawing. Okay, yeah. So how do we calculate this? Let's think about it. We're going to have a bigger circle, right? That's going to be our orange circle that has the highest radius, which is going to be this part right here, right? And then from it, we're going to remove the smaller circle so that we get this ring-shaped thing. So we're going to remove this blue part so that we're left purely with the orange stuff. So this is our A1 minus A2, this ring here, where A1 is given by the bigger radius R1 and A2 is given by the smallest radius R2. So let's think about how we can calculate these. Well, it's fairly straightforward because basically R1, that biggest radius, is going to go just from 0 all the way up to the height of the function, right? Where it touches the graph. So as we can see here, maybe I'm going to erase this, it's going to go from the center to where it hits the value of the function. So basically the radius is whatever the function outputs at a particular value of x, right? And it changes all the time. So basically here we can say that the A1 is just pi times the function squared. So it's just pi times the radius squared. And in this case, we're talking about the red function. So throughout 3 sine of x squared, all of this squared. Therefore, A1 is equal to pi times 9 sine squared of x squared. Okay, and now let's find the smallest circle, A2. Well, A2 is basically just going to go from the origin, and then it's going to touch the curve at the blue line, where that's going to be our radius, and we're going to revolve it to make a circle, right? So thankfully it's very easy. It's just pi times the radius squared, and the radius is the function. So A2 is just going to be pi times the function squared times ex squared plus e to the negative 2x squared. So when we square this, let me FOIL it out. So that's going to give us pi times, let's see, e to the x plus 2 times, let's see, that's 1/2 minus 2. That is going to 2e to the 3x over 2. That's negative. And then plus e to the negative 4x. Let me just double check my math when I fold it. So 1/2, yeah. And then that gives us, when we add these, yeah, that's okay. So when we have a1 minus a2, we're basically going to do a1 minus a2 is just going to give us pi times a1 is 9 sine squared of x squared, and then minus all this stuff. So minus e to the x minus 2e to the negative 3x over 2, and then minus e to the negative 4x. So once we have this, let's just copy that in. So this is just pi times 9 sine squared x squared minus e to the x minus plus, oh, that's minus, right? Because we're subtracting everything. Minus 2e to the minus 3x over 2, and then minus e to the negative 4x dx. Now they want us to evaluate this using our calculator. So it's going to be a long problem, but let's typing it online using Symbol Lab. So that it's pi times 9, let me type that in and see what I get. Times 9 sine squared of x squared, and then minus e to the x minus 2 times e to the negative 3x over 2, and then minus e to the negative 4x dx. So let me put that in. It might take a while to calculate because it's a pretty big expression, and I have an answer. And so this gives us, this is approximately, let's see, 7.519, and that's the volume that we get when we take this area and we revolve it about the x-axis.